Timmy, it's your boy Lil Timmy Tim. Yeah. What up, statistics class? I'm coming through live from G25. Yeah. Live from G25. Let's go. Statistic, yep. Statistic, yep. Statistic, yep. Statistic, yep.
Do you find yourself asking, what is the point of stats? Is the time spent learning it worth it just to pass a class? Well, there's this thing called data. It has characteristics, and making data make sense is the power of statistics. See, a long list of numbers is nice but not quite useful. What we need is to find a way to only focus on what's crucial. And here's where you might think, let me just find the average. Well, that's a great start. Knowing the mean is an advantage. Compared to just raw data, the mean does us wonders. But relying on just the mean would be quite a blunder. To be beyond average, you should go beyond the average. Standard deviation, something you should want to manage. Calculating z-score might be a chore like cleaning, but I bet you'll want to know more when you understand its meaning. To be beyond average, you should go beyond the average. Standard deviation, something you should want to manage. Calculating z-score might be a chore like cleaning, but I bet you'll want to know more when you understand its meaning.
Hello everybody, welcome to my class again, and this is today I'm going to conclude this chapter, representation of data. So this is part 3 of 3. So here in this class today I'm going to discuss about how we solve the problems from representation of data. That means I'll talk about the strategy to solve the problem. So you can see here in this example that the maximum temperature in degrees Celsius measured to the nearest degree was recorded each day during June in a particular city. The temperatures were as follows. So these are the data of temperatures in degree Celsius. So based on this data, draw a stream and leaf diagram to illustrate the temperatures and write down the mode of this data. So here I have kept this ready for you. So these are the values, and by using these values we have to draw stream and leaf diagram. So what you can see here, so first of all we identify which value is the minimum among all this and which one is maximum among the same. So here I can see that if you analyze this, if you have look at this, then you will see that 12 is the smallest value. Okay, so the maximum among all these values is 23. So let's see here what we can do actually. And so what I have done actually, that I have taken 1, 2, 3, 4 rows for 1. It is also possible that you can manage in 3 or 5. It depends on that how you make it clear. So in that case, first of all I am taking 12 to 23. So here key is 1/2, that means 12 degree Celsius. So I am taking from 12 to 13 in one row, 14 to 15 in another row, 16 to 17 in another next row, and 18 to 19, and like this. Okay, so it depends on how we make it clear to the readers. Here in the stream side I have taken 4 ones, and to the digits in tens place, that is 2. So under the heading of 1, my first choice is 12 to 13. So my grouping is like this. 12 to 13 means you have to check this. So it is 12, so we copy out 2. Then let me go forward, and then after that 3. So I am taking here 3. I think before that also there was 112. Okay, so I have taken this as in arranged way. This is in the ascending order, but what we need actually, we require first of all the value of stream and leaf diagram without order. 22, 21, and then another as 22 to 23. It depends on how we make it clear. So in this way our stream and leaf diagram is ready. So you can separate this, separate like this also. So to the left side this is STM, and to the right side it is left. Yeah, this problem said that to draw a steam and leaf diagram to illustrate the temperatures and write down the mode. And you know that mode is the maximum frequent values or maximum occurred values among this data, and that value will be the mode. So in that case, if you talk about mode, you can see that, so this is the frequency of this group. So that is 3. Altogether this is 3 and this is 2. But we have, for the mode, you have to check this individually. So in this case, it is 9. You can see it has been repeated for maximum number of time than the other values. You can see here 1, 2, 3, 4, 5, 6, 7, 8 times. It has been repeated up to 8 times, and this is the maximum number of time that 19 has been repeated than other. So therefore your mode value will be 90. So in this way we can calculate mode from the STM and leaf diagram. This is also possible that you can find the model class. Model class means the class or the group having maximum frequency. So model class, if you talk about model class, so the model class from this group, if you would like to talk about, then that is going to be 18 to 19. That is going to be 18 to 19. Now before we move further to solve the problem, first of all I am going to highlight on some of the formula that we had learned in our class, and then I will again come to the problem solving. So here we shall discuss about formula for x bar, and x bar is the arithmetic mean, and you know that arithmetic mean formula is sum of observations divided by number of observations. That means x bar is defined as summation of fx by n, or you can also write summation of x times f by summation of f, because summation of f itself is n, and this is for the frequency distribution. Okay, for individual series of data, for example, individual series means this is, suppose that 13, 12, 10, and frequency is only 1 given. That means if it is not mentioned here like this, then this is each value has frequency only 1. So this sort of data is called the individual set of data, that you can find all the details in the first part of my class. So for individual series, you can see that x bar equals to summation of x by n. So where summation of x is the total sum of the observations, n itself is again the value of total number of observations. Okay, let's now talk about the formula for standard deviation, and this is given like this. So in this case, this is the formula for the standard deviation. And can you tell me, this applies for individual series or the frequency distribution? So in fact, there is no f over here in the coefficient of x. Therefore, this is for the individual series of data. For the discrete or continuous frequency distribution, we just introduce f over here. That will become the formula to calculate a standard deviation. There will be sign, algebraically there will be sign positive and negative here, but we take only the positive square root, and that defines standard deviation. So we will not take the negative value of the square root. So we take only the positive square root of variance, and that is also defined as a standard deviation. And then little highlight on cumulative frequency also. So what is called the cumulative frequency, that we have already seen before, that we add the varied value one after another, and we write the frequency accordingly by adding every time as we move forward in that given series of data. That is called the cumulative frequency. So in this case, I will explain again that how we find the cumulative frequency for the data. So this is the varied value x, and f is the frequency for each value. 0, 1, 2, 3 and 4 from this line graph. So here you can see along the x-axis, and this is the y-axis actually. Along the x-axis, our variate value is 0, 1, 2, 3, 4. You can see that 0, this is the 0 for the origin. So this is up to you that you may just start this line from 0 also, or you can suppose this 0 somewhere, shift to the positive x-axis, for example, or as it is needed. So I am taking here 0. It can also be done. So I collect all these values of x. So these are 0, 1, 2, 3 and 4. So 1, 2, 3 and 4, and from this line graph I will see that like 0 has frequency 3, so we write here 3, and CF stands for the cumulative frequency. So here in this case I am talking of less or 0. If I write, that means I am talking of x is less or equal to 0, not that x is only equal to 0. If I am talking of here under the heading of x less or equal to, that means it is not that x equal to 1, it is less or equals to 1. And similar thing we apply for 3, 2, 3 and 4. So you can see here the value less than 0 is, there is no value, but up to and including 0 is 3 values. So that frequency value is 3. So we write here 3. Now less or equal to 1 is also the values which are less or equals to 0. That means we have to add 5 and 3, so that is going to be 8. And less or equal to 2, then you have to add all these, because less or equal to 2 means add 2, the f value is 7, so less or equal to 2, that will include also less or equal to 1 and less or equals to 0. And therefore we add further to this, so 8 plus 7 is 15. Last CF value will be the value of n, or otherwise if you add this together, that will also give you summation of f, and that summation of f you can write in 7 plus 3 is 10, 5 plus 5 another 10, and then 4 is, this is 24. Alright, so value of n is here 24. So in that case you have n as 24 plus 1 divided by 2, that is 25 divided by 2, that means 12.5th value or item you can write. Then let's see, it is 12.5, and 12.5 if you look at in the cumulative frequency, so it lies first time in 15. So it is bigger than 8 and far less than 20, so it lies first time in the CF value 15. Therefore median value is 2 in this case, so your median value is 2. And also if you can have look at this graph, that means there is a bit of difference in symmetriness about 0 and 4, there is a little bit more value, but it's very near to the symmetrical curve. If you consider curve from on top of each line, then it looks like as if this is the symmetrical set of data. And by symmetry we can also say that it is median, because median lies exactly at the center, and that central value is 2. So just by direct observation also, even though there is little difference, we can say that the median is 2. And also if you would like to find the first quartile value, so just by usual way you can find n plus 1 by fourth item. That means n plus 1 by fourth item means equals to, you can see here this is 1, so your first quartile value is 1 in this case. Similarly, if you would like to have third quartile value, that means 3 times of n plus 1 by 4. So therefore if you would like to have interquartile range, and you know that the interquartile range is equals to Q3 minus Q1 equals to, your Q3 value is 3 and Q1 value is 1, so 3 minus 1 is 2, that means the interquartile range is 2. So in this way you can do a lot of calculation and analysis by using the cumulative.
You have two groups of people and want to know their ages, so you write their ages one by one on 2 separate pages. Now everyone in group 1 is 20 years old, which makes their average age 20 low. And behold, group 2 has a different story, cause half the people are 10, but the other half are 30, so the average is 20 again. These two groups are quite different, that's what we want to claim, but just looking at averages we saw they were the same. Now let's make a new friend, sigma, or standard deviation. It's a tool that'll help us make sense of this little complication. It measures how far the average is from each individual. The formula looks scary, but applying it is really cool. The gist of it really is how spread out the numbers are, which means sigma is higher when all the numbers are really far. So group 2 has a high sigma, group 1's is actually 0, and if you can now see why that's true, you're a sigma superhero. To be beyond average, you should go beyond the average. Standard deviation, something you should want to manage. Calculating z-score might be a chore like cleaning, but I bet you'll want to know more when you understand its meaning. To be beyond average, you should go beyond the average. Standard deviation, something you should want to manage. Calculating z-score might be a chore like cleaning, but I bet you'll want to know more when you understand its meaning.
Okay, let's see the data like continuous set of data, and then we'll see that how to find the cumulative frequency. So in order to find the cumulative frequency in continuous set of data, what you can do, you have to take the boundaries like 5, 10 and everything, and their frequency are given. So based on this frequency we find cumulative frequency in this case. So you can see here that if you are talking of in this case, then it is 5 means it is less than 5. So how many values are less than 5? You can see there is no value is less than 5, because if you talk about this this class interval, for example, that means x is less than 5, less than 10, and is bigger equals to 5. So there is no value less than 5. Therefore we can write the frequency 0, and the value which are less than 5, less than 10 are 18. And let's check the total frequency f. In this case is 8 plus 3 11, and 5 16 17 18. So the last cumulative frequency is in fact the total frequency. Alright, so in this way we can find the cumulative, we can construct the cumulative frequency table from the given class interval. So this is in fact this is table in this case. So in order to draw the graph, what we can do actually, we keep all the class boundaries on the x-axis, and the corresponding cumulative frequency you can plot along the y-axis. So here along the x-axis and also along the y-axis you have to scale the graph. Alright, so with a proper scaling, I have these points from x data, and along y-axis this is from the cumulative frequency values. So here in this case you can see that the CF for 5 is 0, so I mark it at 0 either by dot or cross. And for CF value 10, for the x value or less than x value 10, the CF value is 8, so it will go somewhere 8. It is here. And then for 15 it is 11, so for 15 it is a bit below than 12, so we here somewhere. So you have to take the scale and a proper graph, and then you have to plot this. That we'll discuss later. And then 20 has CF value 16, so we'll go somewhere here from 20. Okay, 16. And finally we have 25. So 25 has frequency 18, so it must be somewhere here a bit upper than that. And finally we take a scale and we join this sort of line by a straight line this way, and this sort of graph you obtain we call the cumulative frequency graph. And from this graph we can have a lot of information. So here in this case, like for example, if you would like to find median, for example, you want to find median, for example, then what you can do, you can find by n by 2th value in the graph, and n by 2th value means here in place of n we have total n as 18, and then divided by 2, that means we have 9th values, and the 9th value is, how can you get this 9th value? So you go along the y-axis in the CF and then find 9, so it is somewhere here about this point. Just draw the line like this, and when you drop a line vertically that is perpendicular to the x-axis, and read of this value, that value will give you the value of median. So at this point, I have not taken the proper scale actually practically on the graph, but I can show you the location, that this is the location of median that we have got on the basis of n by 2. Similarly, Q1 value you can obtain by using n by 4. So yes, 13.5th value. So in order to find 13.5th value, you have to go along the y-axis, and on the y-axis you have to draw a line horizontal to the x-axis. That means it should be at 90 degree. Take a scale properly and measure like this, where it touches the graph. You drop down onto the x-axis. Then on the x-axis, this value will give you the value of Q3, that is the upper quarter. So from cumulative frequency graph, you'll be able to find so many information. Like here, the one I have done for you to understand that how to find the quartiles. And in addition to finding all the quartiles and medians, you have also a lot of information that you can get it from the cumulative frequency graph that you will see while solving the problem later on in the same class here. Okay guys, let's now talk about how to find cumulative frequency from the grouped data. Now, by dint of this sort of information, I have every time x and y coordinate, and by using these values along the x-axis and y-axis, my graph is like this. This is called the cumulative frequency graph. So this is not to the scale actually. This I'm just going to outline the fact that outline the method that how to calculate quartiles, and how to develop other sort of things from the given sort of graph that we obtain from this series, but the graph is not to the scale. And so just earlier I had explained that how to find Q1 is that. So what you do actually in the total, so in order to find the Q1, you write n plus 1. So n value is 48. So 48 plus 1 divided by 4 value is 12.25. So you have to search along the y-axis, because along the y-axis we plot CF, and along the x-axis we plot all less than values for x. So definitely n is along the y-axis, therefore we take n from the y-axis. So 48 plus 1 by 4, fourth value gives you the first quartile, so that is 12.25. So 12.25 you have to search here, so it is somewhere here. Then go parallelly with the x-axis until you touch the graph, and once the line has touched the graph, drop down the perpendicular over here and read off this value. This value will be the value of Q1. So here I am not writing what is the value of Q1, because this is not to the scale, but if you draw the same thing on the graph, you will find all the situations over there. So I'm just telling you that how to locate the quartiles and medians in cumulative frequency graph. And similarly, Q2 value is 24.5. So from here you just go like this and read off here. This is the Q2 value, and similarly you can read off the value of Q3. Now what I am doing here now, so it is the position of Q1. I marked the position of Q1, and then Q2, then Q3. Then what I have taken, actually taking reference of Q1, Q2, Q3, I am considering this box. You can see that this line for Q1, another for Q2, another is Q3. And also I have taken this maximum value among the whole set of data, and the minimum value also I have taken into consideration. And by taking all these 5 sort of things, I have drawn this sort of the diagram, and the 5 information I have taken is called 5 summary data, and by dint of these 5 summary data, I have this sort of diagram. This is called the box and whisker diagram. So this is actually inside is the box diagram, and outside that is containing the minimum and maximum value thing. Then these are called the whisker. So in combined, we can say that this is the box and whisker diagram. What is the use of box and whisker diagram is that we'll be able to find a lot of information although, but most obviously you can see that it tests the variability of the data. So here in this case, if your box is like this, you can say that there is more gap to the right side of Q2. That means Q2 is near to Q1. So in this case, as this gap is big in the right side, so if this sort of thing, if you find from the data through your diagram, then or if your box and diagram looks like this, that means your data is called the positively skewed because there is more gap towards right. And sometimes it is also possible that, so this is from this graph actually I have taken without scale. Sometimes it is also possible that your Q1 position might be like this. You can see there is more gap towards left than to right. Then in that case, the data is called the negatively skewed. That is, it is derived negatively in the skew sense. Skew means lack of symmetry. So this is not the symmetry. Okay. And for example, suppose that your Q is exactly at the center. That usually you will not get practically, but if that is very nearly at the center of this box, in that case both sides you consider the area as equal, and this sort of information if you get from your data, then you can say that your data is symmetrical. So this is the way that we draw the box and whisker from the cumulative frequency graph. And also once we have box and whisker diagram, then we'll be able to say the variability of data, whether this is positively skewed or negatively skewed or symmetric, or also it will be helpful in finding the growth rate, or the better rate in term of some sort of information that we deal with. Okay guys, let me remind you about the formula of arithmetic mean and standard deviation of variance by coding method. Coding method is also called that assuming method. So in that case, you have learned about this formula and this formula, and also this is important to remember all this. Even though you can find this in your formula booklet, this is good idea to remember. So for example, you usually remember that sigma equals to summation of x squared divided by n minus summation of x over n whole square. But how to remember this when you are going to code? So instead of here x square, so in x square you just write wherever you find x, there is x minus a, then a square, and here also minus a. You close this. Okay, x minus a, then whole square. So this is easy to remember the formula in the coding form also. The arithmetic mean also, what you can do, arithmetic mean formula, you know that this is in general by direct method, this is summation of x by n. Then only the thing that you have to do is that you have to write here a and then plus a. So that sort of thing you must remember in order to deal with the problems in this chapter named representation of data. I would like to little bit highlight on what is A actually. A is arbitrary value. This is also called the assumed mean. So A can be any constant in general, but in the statistics, what is the tradition is that A we choose from the given set of data like this, where you find or where you feel by estimation that is supposed to lie at the center, at the average position of the given series of data. So this is the criteria that you choose the value of.
Suppose you've made a painting that you're looking to sell. The mean price is 200, but your painting's rather swell. So yours will be above the mean, that's something you can tell. You sold yours for $250, so it seems like you've done well. $50 above average, so you're feeling content. But you wonder if your painting was in the top 1%. Is 50 above average really all that high? Well, that depends on whether other prices are nearby. So what we need to quantify is how prices are spread out. But we already have that, sigma without a doubt. So now how many sigmas above the mean are we? There's actually a name for that value, it's called Z. So let's recap what Z-score means. A name might seem bizarre, but all it says is how many sigmas from the mean we are. So if sigma is 50, well then that tells us a ton. We're 1 sigma above average, so the Z-score would be 1. Let's say you did the math and found your sigma to be 10. We're 5 sigmas above average, so the Z is 5 then. The cool thing about Z is that it has its own table, which lets us solve problems we were previously unable. You're in the top 1% if Z is 2.3 or more, and since our Z is 5, we're in the 1% for sure. I hope you now can see how to come to this conclusion, and that sigma and Z are no longer a confusion.
Okay, we shall now discuss about some of the examples here. So example states that 31 people completed a jigsaw in the following times x minutes. So you can see this is jigsaw, and it states that 31 people completed a jigsaw in the following times in x minutes, and data for the time in minutes are given like this. And then for this data, question number 1 says that to calculate x bar and then to calculate the standard deviation. All right. So what you can do in this case is that, unless otherwise stated, if you know the function in calculus, in calculator, then you can use that function in calculator. Otherwise, you can do by summation of x over n, and then you can calculate your x bar value, or in the way you feel it easy. If you'd like to calculate it directly from the calculator, there is a function in calculator under the mode, and then you can search for the stat or mode somewhere and learn to calculate x bar and also the standard deviation. So you don't need to use any formula if you are using the calculator, unless otherwise stated in the question itself. And another step is that the following rule can be used to identify usually high or low value called the outliers. So here in this case, in question number 3, so before question number 3, it suggests that an outlier is less than x bar minus 2 times of standard deviation, or greater than x bar plus 2 times of standard deviation. So any value greater than this or any value less than this from the given set of data will be rejected. So you have to check it out. So here now we calculate x bar minus 2 times of standard deviation. So I have taken x bar from here and then standard deviation value from here again. Standard deviation is 29.7, and we can put it over here. Then we have one value as 4.93 and another value as 22.81. And now just compare this. Can you find any value less than 4.93 in the given set of data? I don't think that we have any value less than that, because it looks like 11 is the least, I think. That means we don't need this sort of value in order to accept or reject, in order to reject any value from the given set of data. But you can see 122.8, so you take it as maximum value, that should be here. So any value bigger than 122.81 will be rejected, and that will be called the outliers. So let's find which values are bigger than 122.81. So if I talk about 144 is bigger than 122.81, and also if can you find another value which is bigger than 122.81 in this data. So let's check it. Yes, that is 133, and these two values are the outliers for this set of data, because these two values do not fit to this data according to the criteria defined here. In this way we can find the outliers. I'll now go to another question. At a bird observatory, migrating willow warbles are caught, measured and ringed before being released. The histogram illustrates the lengths in millimeters of the willow warbles caught during one migration season. So this is the situation given. Complete and copy the frequency table. That means you have to have observation over this histogram, and then you have to copy and complete this. So what can you see here, that it is given that length in mm from 100 to 105, 105 to 108, 108 to 110, and like this up to 122, and then you have to put the frequency value over here. So in order to put the frequency value over, you have to analyze this graph. You can see here, this is frequency density given, and this is the values of the class boundaries are given, and by taking these two pair of x and y, a histogram has been drawn here. So based on this histogram, so let's check it how it goes. Like in this histogram, so first of all, if you talk about class width C, for this is in fact 5, and you know that frequency is equals to class interval times frequency density. Okay, so class interval we have 5 for this, and for another class you can see we have class interval as 105, 108. So 108 minus 105 is 103. So difference is 3 over here. So you have to look at the difference between the class boundaries in order to find
F. So let's first of all talk about 100 to 105 class interval. So you can go to the histogram, and in the histogram you see that this difference is 5 and the height is only 1 unit. So first of all, you have to, before going to use this histogram, you have to first see that what scale has been used along the x-axis as well as along the y-axis. In general, the scales are not mentioned in the problem area, but you have to understand that what scale should be here. So let's see along the x-axis. You can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 100 to 105, the difference is 5, but the small square counts is 10. That means 2 small units have been taken as 1 mm. That you have to understand. Okay. Now let's go along this way. So it is 4, it is 8, and this is 12 and 16. You can see. Then what you can find here in this case. So 1, 2, 3, 4 unit. 1, 2, 3, 4 units. So along the y-axis you can see 1 a small unit in the graph is counted as 1. Okay. So frequency is the number of things. So it is given in terms of frequency density. You have to find the frequency. So here in this graph, you can see that C value is 5 plus width value is 5 and its height is 1 inch up. And you know that the area of each bar will give you the frequency of that class interval in that in the bar. So here in this case, you can see that F, if you want to find F means, that is frequency means C times of FD, and you can see here the value of C as you can see here 5, and value of FD corresponds to the height of the bar. That means it is 1, so its frequency is 5. Okay, so this is the way that we derive frequency directly from the given histogram. And for the class interval, let's check another class interval 5 to 8. You don't need to write this formula, just you can read it off from here. Now, so 5 to its width is 105, okay, to 108. So you can have a look at here, 108 is not mentioned here, but we have to understand that how it is 108. So 108 must be at this position. So area of this graph is, now the height you can see here, up to here 5, 6, 7. So height is 7 at this point. So width is 3 and height is 1, 2, 3, 4, 5, 6. 5, 6. So 6, 3 are 18. So frequency for the class interval 105 to 108 is 18. And then lastly it is 5. Let's check whether or not this is 18. So 18 is for 114 to 117. So it is for 114 to 117. So you can see here 114 means this is the point 114. Yes. So no, this is 110. This is 100. This, so 114 must be here because this is 150. So 114. Yes, 2 steps behind. So 114 to 117. Then 1, 2, 3, 4 units means 2 according to that, and then it is going to be 117. So from 114 to 117, the gap is 3, and the height you can see here up to here is 4, 5, 6. So it is 3 is the class width and 6 is the frequency density, and therefore this is 3, 6, 18. So this is correct. All right. So in this way you can fill in the table the values of frequencies directly from the histogram, provided you have this sort of thing in your mind. So in general, what you can support that, if you find as class boundary values have been plotted against x-axis and the FD along y-axis, in that case just you derive the small square unit along the x-axis and along the y-axis. So if you just multiply the width and height of each bar, then in that case you will get the frequency for each class intervals in general. Okay, but yeah, we still have few more things to explain here. Yes, state briefly how it may be deduced from the histogram without using calculator that an estimate of the mean length is 111. And explain why this value may not be the true mean length of the Willow Warble's chord. Okay, so first of all, this question asking you to estimate the value of mean length. So mean length means you can, if you think on this histogram, you can see that if you draw a line of symmetry, for example, so not exactly, yes, it looks like exactly, yes. So this histogram, if you consider the curve something like that, as we did it before, and then your curve looks like this is symmetric about the point in x-axis is 1 1 1. So as the data is symmetric about x equals to 111, therefore from the graph your x bar is going to be, or arithmetic mean is going to be equals to 111. Now do you think that this value is the exact mean of the given sort of distribution? Definitely not, because this sort of mean we have taken from just the midpoint of only one class interval, that is 110 to 112, and this is the reason why this mean value that we have estimated directly from the graph may not be the true mean length of the Willow Warble's chord. Okay, next, from this information we have to estimate the standard deviation of the lengths. In fact, we calculate the standard deviation of the length, but it said that to estimate, because we don't know that although there are 5 values in between 110 to 105, we may not know that which values are there. Therefore, even though if you calculate it, that will not be the exact calculation, that will only be the estimate of the standard deviation. So in order to calculate this, so let's first of all write down this is 105. Let me copy this out first. So by using the calculator, we found the mean value of this, and now in the formula you require x minus f. That means you require fx value. So your fx value means, in fact, we are multiplying f and this mid value. So when you multiply this value, let's multiply what is there. If you multiply this fx means, or xf, both way you can write. This is 5 times 102.5, and that is going to be 512.5. So that is 512.5 f and x. Now have a look at this formula. So if you look at this formula, what you require, x times f total, that is fx. It is also like this, it is summation of fx by n. So both are the same thing here. So what you need here in the information, so first of all you have to write the formula and have a look the things that you require in the formula, and then develop your table accordingly. So it is summation of fx, column for the summation of fx, and then you add up all these value now, then that value is going to be here 13098. So this is the value of fx. So now by using the value of fx, you can put here 13098 divided by total n is 118. 098, divide this by 118, and your value is 111. So fortunately you have got the value of x bar as 111, and in the figure also you have seen that by symmetry also this value of x bar is 111. So x bar we have obtained now, but this question says that to estimate the standard deviation of the lengths. That means you require the standard deviation formula. So let's see which one is easy for you actually. So one way, that summation of f x minus x bar square by n. Another formula is summation of fx square by n minus x bar square, and in x bar you can directly write over here that summation of fx by n also, but I feel this is easy for me to calculate. So in this case you develop another table in order to find f times of x minus x bar square. And one more thing I want to discuss here, although this is not the part of the question. So let's see the values of c in each case. So value of c here is, let me come through to the, so value of c, if you consider here, it is 5, okay, and here the difference is 3. In another class interval the difference is 3, and here another difference is what? 8 to 10 is 2, 10 to 12 is 2, 12 to 14 is again 2, 114 to 117 is 3, and 117 to 122 is 3 plus 2, that is 5. So that sort of thing is 5. Yes, height is 1, so it is 5. So I think you have seen all these values. What I have done, I have taken all the values of c, and then let me find c bar, that means the mean of this difference. Let's see what happens. So it is 5 plus 3 is 8, 10, 12, 13, 14, 15, 16, 17. So this is 17 plus 5 is 22, and divide this by how many c's are there? You can see here 1, 2, 3, 4, 5, 6, 7. So you divide this by 7, and my value for c bar in this case is, it is 3.14 up to 3 significant figure. So 3.14. Let me check. Yes, up to 3 significance figure. Then can you tell me that this is not sigma square, this is sigma? So can you tell me that this c bar and this is 3.14? So if you match up or compare these two values, you can see that these two values are very near to each other. So sometimes this is also possible to roughly estimate the value of sigma from the class interval size. Okay, so this is not the hard and fast, and this is not the specific method to estimate or calculate the value of sigma, but sometimes if you require the common sense that what would be its sigma value, then sometimes you can go through this way. And this is the A level exam question, and you can see that this question states that a summary of the speeds x km/h of 22 cars passing a certain point gave the following information. So these are the information given, so you note it down, and then it says that find the variance of the speeds from this information, and hence find the value of summation of x squared. Okay, so in order to find the variance, let's see what we can do here. So you have to note that first of all, and I had explained in my previous two classes, and I had highlighted on the formula by coding method in this class also, and my x bar value, x bar formula by using the coding method was summation of x minus a divided by n plus this a value, and sigma was, so variance means you have to find sigma squared. So sigma squared was under the root, it was summation of x minus a squared by n, and then minus it was summation of x minus a by n whole square. Okay, so this sort of formula, it is better you remember this, even though this is given in the formula booklet. So for example, if I'm going to find the variance, then what I can do actually, like, so here my variance value is in the sigma square you don't require the root. Okay, so sigma squared by coding method is summation of x minus a squared by n minus summation of x minus a by n whole square, and summation of x minus a means here in this case it is summation of x minus 50 square, because the arbitrary value is given as, so here a is given as 50, So as arbitrary value is 50, so use 50 divided by n minus inside the bracket or summation of x minus 50 again divided by n value. We have n value mentioned here. Yes, this is 22. So you can write here 22 and here also 22 whole square. And then you can calculate this. So before calculating that, we have to put this value over here. So it is given as x minus 50. You can see that x minus 50 square equal to 671.0 divided by 22 is already here, minus inside the bracket summation of x minus 50 is 81.4, and then this is 22, that is the n value, this is whole square. Okay, pay attention here that sometimes we make mistake in looking at these values, so we have to see these values, how the informations are given here. So we have to look at all the information carefully. So this is for the sum of a square and this is only the sum. All right, so similar sort of thing we have to use, consider in this formula also. So here we keep only the sum values and whole thing will be squared, but in this case we keep the summation of x squared values in the difference of x and 50. So summation of x minus 50 squared is this, so I wrote here 671.0 and divided by 22, but summation of x minus 50 is 81.5, and then I wrote this 81.4, so I wrote this only 81.4 and divided by 22. This is the n value as it is mentioned here. And finally we have to take calculator. Then from the calculator we have 671.0. I need to write 0 in calculation, but make this habit because it signifies some figure. Okay, so that is only in order to we have to make the habit to write how it is given. So it is divided by 22, then minus, close the bracket, this value is 81.4, then divided by 22, close this bracket, then square it, and our answer is 16.81. Okay, so this is our answer, 16.81. And if you like, you can also calculate x bar, whether or not at this moment the question asked you to do, but we are going to use this. So x bar by coding method is x minus a divided by n and plus a, and then it is x bar minus a means it is x bar minus 50 here. So we can write x bar minus 50 value is 81.4 divided by n is 22 and plus a is, you can see here in place of a there is 50, so you can write here 50, and that is equal to, this is, if you use the calculator, it is 81.4 divided by 22 plus 50. Okay, so from calculator, by using calculator, this is 53.7, so x bar value is 53.7. So we keep this value. If we need, then we can use, otherwise we just leave it as it is. And now another part of the question says that find the variance of the speeds that we have already got. This is the answer. And now hence find the values of summation of x squared. So this question is testing your skill in algebraic derivation of the things. So in order to find that, let's see, it is, so here for the second part, we know without coding. Okay, so we know without coding sigma square as sigma square equals to summation of x, only summation of x square, because this is for the individual series if f is not introduced here, and then divided by n minus x bar square. So this x bar you can use over here, or otherwise you can write summation of x by n whole square. So this is up to you that how you make your work easy. There are different ways that you can do this sort of problem. So here it is, sigma square value is already here 16.81, and then summation of x square we don't know because we have to find this, we have to obtain this summation of x square. So we just leave it as it is. And divided by n means n value is 22 minus x bar square means what you can do is here 53.7 that we have got from there. Okay, and then it is squared. So therefore, by using algebra, your x square is going to be equals to, if you transpose this to the left and if you write and if you copy in the right side, it's going to be 16.81, and this negative sign will become positive here, and then it is 553.7 whole square, and then this whole thing is going to be divided by 22, because if you transpose to the left side and keep it to the right side, then it's going to be 22. So let's calculate. So using the calculator, this is 16.81 plus 53.7 square, then equal, then times 22. So it's going to be 63811. Okay, so in this way you can find the information that has been asked in the questions, and it was summation of x square. We have another question here now, and you can see that this is a cumulative frequency graph for two countries given. That means we have some sort of comparison between two countries. So what kind of comparison? This is given in this statement of the problem here. So the problem states that the birth weights of random samples of 900 babies born in country A and 900 babies born in country B are illustrated in the cumulative frequency graph. Use suitable data from these graphs to compare the central tendency and spread of the birth weights of the two sets of babies. And this is from Cambridge paper 62Q3JIO. So this is a kind of Cambridge question, and from here what you have to do actually, by taking these two graphs for 900 babies in each country, and then you have to find the average, which average weight is bigger and less, and whose where is the variability of data, so whose variability in data is high. That sort of thing you have to calculate, you have to estimate and analyze this graph. So this question says that the birth weight of like this. So let's go to the, yes, use suitable data from these graphs to compare the central tendency and the spread. Central tendency you can find in the form of average. Average means mean, median, mode. All these are called the central tendencies, but from the graph you have to see that which one is quick to find and which one is more suitable in order to estimate from the graph. So you can, we have earlier discussed that the medians and quartiles can easily be read off from the graph. Therefore, we take median as the central tendency for this sort of problem. So here in this graph, what you can estimate actually, like work for country A. Then in country A, if I talk about the value of median, if you want value of median, that means value of median will be given by n by tooth item. N by tooth item, that means n by 2 means, so n is 900, so this is 900 by 2, that is 450th item or value from this graph. So dark line is for, dark graph is for country A. So from this dark graph, you can read off this value of median is, so 450, that is. So that is 450 means it is 400, and you have to understand the scale first of all, that how it is used here. Okay, so it is 200, this is 450 here, so 450 is somewhere in between 400 and 500. So 1 2 1 2 3 4 5. So third item 1 2 3. So here this is in between this. So just you move your hand like this, and then let's check it. Where is it? So it 450 touches here, and if you go all the way down to here, it looks like it is 2.0. Okay, so this should be based on your skill. Sometimes it might be different than what you have estimated, but if there is little difference, it doesn't matter. There can be a lot of error. Maybe this graph may have some error while copying and printing this, and maybe our eyesight has some error. So there are different errors. So practically it doesn't matter if you suffer few error over here. So for example, if you find 2.1 and something like this, that will also work, but there shouldn't be the big difference in reading of the value. And if I read of the value of first quartile, for example, and now if I do the similar work for country B, what I have found here, like for country B, I have found Q1 value as 2.1, Q2 value, that means it is median, is 3.8, and Q3 value I have found as 4.4. Now let's compare. So comparison. So comparison means better if you copy out all these things together. So let me copy out here the same question for country A information and for country B information 2.1. So it's going to be 3 and then point and then 4 minus 2 is 2. So this difference is 2.3. And then based on all this information, you have to write the conclusion is that you can see here if you compare these two data. So central tendency in this case is 2, and the central tendency, that is median, that is the average weight is 3.8. So for country B, the babies weights are higher. Okay, and if you have look at the interquartile range for country A data and for country B data here, so in country B you can see this value is bigger than that for country A. That means data is more variable in country B. So data for weight, that means the weight distribution of the babies in country B is more variable. So how do you write this conclusion is that country B has heavier babies, and it also has greater spread of the weight. So based on the information that we have got from this graph, we found all quartiles value, and the middle quartile is in fact the median, and it is talking of the central tendency. So central tendency means simply the average, and median is also an average, and this is very appropriate for this sort of diagram, this sort of graph. We took median as the average, as the central tendency.
It's Timothée, about to hit him with the ZTST. Let's do a problem, let us see the probability you see me on TV. 1000 trillion%. I'm a statistical wonder, a statistical gem. 1 in a zillion, about to net a million. Fruity colors on these numbers, call it a chameleon. Statistics, 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 statistics.
Okay guys, in this example states that the following back-to-back esteem and leaf diagram shows the annual salaries of a group of 39 females and 39 males. So this is the information about the salaries of 39 females as well as for the 39 males, and it has been represented by the back-to-back esteem and leaf diagram you can see here. And also have look at the key, how it is defined. So it is 20 and slash 3 means 203, and as salary is given in term of hundreds of this item. So 203 times 100 is $20,300. So 23 means $20,300 for male. Male is towards right side of this, right side in the back-to-back estimate leaf diagram. And for the female, if you talk about 20/2 means 202, and then times 100. So then times 100 means this is going to be $20,200. Okay. So based on all the information, you have to find the median and the quartiles of the females' salaries. Alright. In order to find the median and quartile, what you can do is, here in this case, you can see it is given 39 females and 39 male. So value of number of female, this data is for female, that is 39. And if you would like to find median, what you can do actually, it is 39 plus 1 divided by 2 is equal to 40 divided by 2, that is 20th value, or you can say 20th item. And in order to find the first median, that is also second quartile. Okay, so you count that 20th value in the ascending order or in descending order, but make sure that before you find median and quartiles, this must be in order. So fortunately in this case the values are in order. Okay, so 20th item, if you count it like this, 1 2 3 4, you can see these things are given the bracket, so that is that will also be helpful in the numbers in the bracket, that it is the frequency in each estimate leaf part. All right, or otherwise you can count also the 20th value like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So 20th value is 7. 7 means this value is 227 and then times 100 according to how key is defined here. So therefore our Q1 value is 21,700. Sorry, this is not for the quartile, this is for the median, second quartile. Therefore our value is 22,700 over here. Now in order to find Q1 and Q3, so Q1 value, just you take, this is the median and lower half is below this median, so all these values in the estimate leaf diagram are below the median value. And if you take the median of the upper half, that will give you the first quartile. So median of the upper half is going to be, you can see that up to here is 20, so there are 19 values, okay, up to 8. So if there are 19 values, then your first quartile, median of the first quartile will be 19 plus 1 divided by 2 equals to 10. That means you look for 10th value. So let's see how you look for the 10th value. So here in this case, you can either go through the ascending order or in descending order. So I am taking at this point in the, so in order to count this, it is 210. So you count this value, it is 1 2 3 4 5 6 7 8 9 10. So I counted in the ascending order, and this is the position of first quartile, and the first quartile value from this estimate leaf diagram you can find here 217. It is 217, but times 100 you have to take according to the key. So therefore your first quartile value is 217 times 100, and therefore this is 21,700. And in order to find the upper quartile Q3, you do the similar work, but you find the median of the upper half values from this Q2 value, and this value you can find is again towards the upper half. There are 19 items, so you have to look for about after 7 the 10th item, and that 10th item is 0, and that means actually Q3 value is in front of 0 24, so it is 2 4 and then this is 0 and then it is times hundreds. So therefore Q3 value is 24,000. So all are in dollars. These are in dollars. So we answered question A. Now you are given that the median salary of the males is 24,000. All right. So for the male information, also you are given that Q1 value and Q3 value. So we are lucky that we didn't need to do all those sort of work here because it is already given. Then what further work we have to do is that to draw a pair of box and whisker plots in a single diagram on the grid below to represent the data. So by taking the information of quartiles and the minimum and maximum value that you obtain from here, you have to uh, draw a box plot. So you can see that this is box and this parts are called whiskers. So overall, you can say that this is called the box and whisker diagram or box and whisker plots. And simply if you say box plots, that means this is the box and whisker diagram. So what I'm doing here that I'm taking the 5 summary data. 5 summary data means there should be minimum value, 3 quartiles values and the maximum values that we obtained from the given information. So here in the form of back-to-back estimate leaf diagram. So here in this case, in the graph, it was given nothing, no scales were given, then we have to develop a proper scale. So what I'm taking here, 20 means I'm taking here 20,000, 21 means it is 21,000 here. So what does it mean? If you write 20, that means it is 20,000. If you write 21, scale 21, then it is 21,000. Or you have to decide that what should be the proper scale so that you can make your presentation meaningful to the readers or to the audience. Okay, so I have designed a scale like this. 20 means 20,000 and like this. So it is 20 to 21. If you count this gap, 1 2 3 4 5 6 7 8 9 10. So 20 to 21, there are 10 counts in the small square. Then what can you say about this point as this is 20.1, 20.2, 20.3, 20.4, 20.5, 20.6, 20.7, 20.8, 20.9, 20.10 means it is 21 already. So if you say it is 20.1 or 2 if you have counted, that means every time you are multiplying with 1000 in this case because I am taking the tens digit only. If I take 200, then I multiply by 100 only. So that will be mean actually 2, 2 and 0, 0, 20,200. So this is up to us that how we make the things clear. It depends on our practice and common sense. Okay, so first I am working for the box and whisker plot for the females. So these are the information. This is 21.7. So what I have done for female is that this is 21 and 0.7. It is 21,700. If you divide by 1,000 in order to plot this graph, then this is 21.7. So I have counted like this 1, 2, 3, 4, 5, 6, 7, and my Q1 value is here. So I marked Q1. And for median, it is 22,700. That means I have to count 22.7 if you divide by 1,000 in your scale here. So 22.7 means it is 1, 2, 3, 4, 5, 6, 7, and I'm here. So this is the position for second quartile, and similarly 24,000 you can count from here. So this is the position of Q3. And in the female case, if you have look at the minimum value, it is 200. That means it is 200 times 100. Okay, so minimum value is at where it is at 20. 20 means times 1000, that is 20,000. Minimum value is the 20,000. And the maximum value, if you talk about, maximum value is 265. Okay, so when it is 265, so you take 265, you are now able to count this. So 265 is here, and so this is the maximum value. So by taking all these 5 data summary, I took the reference of all this, and about this line I took an appropriate width here and here, and then I completed this box about Q1, Q2, and Q3, and extended this left to the minimum point, and from here right to the maximum point. And I did the similar work for the males. salary, I will say, and that is also females salary, and my box whisker float is like this. Okay, so in this way we answered question number B also. Okay, lastly we have one more example here, and you can see that this is a histogram, and along the y-axis there is frequency distribution, and along the x-axis there is a speed of car gear. And let me read out this problem first of all. So this problem states that a policeman records the speed of the traffic on a busy road with a 30-mile-per-hour speed limit. He records the speeds of a sample of 450 cars. The histogram in figure 2 represents the results. Calculate the number of cars that were exceeding the speed limit by at least 5 miles per hour in the sample. Estimate the value of mean speed of the cars in the sample. Estimate to one decimal place the value of the median speed of the cars in the sample. Then in D, comment on the shape of the distribution. Give a reason for your answer. And lastly in E, it is state with a reason whether the sample of the mean or the median is a better representation of the average speed of the traffic on the road. So which one is better estimate? You have to give the reason whether this is mean or median. So first of all, have a look at this diagram. This is a kind of histogram. It is also said that this is a histogram, but usually we have seen that in histogram all the bars are connected. You can see that these two bars are disconnected. It looks like non-continuous class interval. Is that true? The answer is no. Why? Because here you can see that 10 to 15 has some frequency density. You can read it from here. And 20 to 30 class interval has this frequency density. And for 50 to 20, you can say the FD value is 0. In fact, its frequency is also 0. That means this class doesn't exist. Means it doesn't mean that this is non-continuous class interval. You can say that the frequency or frequency density for 15 to 20 is 0 in this case. Okay, let's move to the question. It says that calculate the number of cars that were exceeding the speed limit by at least 5 miles per hour. At least 5 mile per hour means you can see that the speed limit is 30 mile per hour. So if the speed goes higher than this amount of mile per hour, that means this is the over speed. And according to the question, it said that it exceeds at least by 5 mile per hour. That means it is talking of a speed of 35 mile per hour or more than 35 you have to see. So then you have to find the number of cars in this region. Okay, so first of all we work out with the scale here. So in order to work out with the scale, you can see that here from 10 to 15, if you consider this box, big box I'm talking, then in each box you can see there is 1 2 3 4 5, and upside also it is 1 2 3 4 5. So there are 25 smaller boxes inside one box. And how many boxes are all together here? You can see here this is one complete box, and this is the half complete box. Rest above than this. Okay. So first of all, let's count how many boxes are there. Big box. So 1 2 3 4 5 6 7 8 9 10 11 12 13. So here it is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21, and half boxes are one half another half, then 22, and this half upside, this half is, it makes 22 big box. So there are 22.5 big boxes.
in the graph. Alright, then how many small boxes? You can see 25 in each in each big box. There are 25 small boxes. So we have here times 25, and that is equal to, you can see here that 22.5 times 25, and it makes 562.5. So this is 562.5 boxes. Fine. So now let's see that here now. Speed limits. So in question number A, calculate the number of cars that were exceeding the speed limit by at least 5 miles per hour. So at least 5, so exceeds a speed limit by at least 5 miles per hour. But you can see that the speed limit in this case is 30 miles per hour. That means this question is talking of greater than 35 miles per hour speed. Then how many cars have the speed exceeded at least by 5 miles per hour, but the car has a speed? How many cars have speeds at least 35 miles per hour? In this case, you have to find here. So in that case, you have to go to the diagram, and then you have to find the frequency of the cars which have over a speed about 35 and more miles per hour. So it is more than 35 means it is 35 to 45 miles per hour. So how many squares are here? Biggest square I will count. 1, 2, 3, 4, and this is half. So this is 4.5 half. So we have 4.5 big squares represent the number of cars that have a speed more than 35 miles per hour. Okay, so big square I am counting here now. So what will be then number of cars? Therefore number of cars in this case is going to be equal to 4.5. so in this case also you have to work that the total frequency in this case is given as, you can see that the total number of car is 450. So 450, and now you can say that how many boxes we have? 22.5 big boxes, means there are 450 cars. Alright, there are 450 cars. Then in one big box, how many cars should be there? By using unitary method, there should be 450 divided by 22.5. If you calculate this, just calculate, it's going to be 450 divided by 22.5, and this value is 20. So each big box represents how many cars? 20 cars. 20 cars. But how many boxes are here? 1, 2, 3, 4 and half, that is 4.5 boxes. So therefore the number of cars which has exceeded the speed limit above 35 mile per hour, at least means greater equals to, sorry, you have to write greater equal to, okay, is, so total number of boxes is 4.5, and each box has 20 cars. That means you multiply that with 20, and 20 times 4.5 is going to be 90. So number of cars in this case is going to be 90. So your, in this case, question number 1, so number of the cars is 90 which have exceeded the speed by at least 5 miles per hour. Now what you keep the a small box? Let's see here. So 22 big box means how many small box? We have seen it just now here. Yes. So 562.5, a small box contains 450 cars. Then each small box contains 450 divided by 562.5, and if you calculate this, it's going to be 450 divided by 562.5. This value is 0.8. 8. You can see that means one small box has, a small box means, so box inside this box, so a small box has how many cars? 0.8 cars. And then if you would like to calculate, so therefore the number of cars equals to number of a small box in this case, and times, it was 20 before for the big box, but for the small box there are how many cars? 0.8 cars. So it is 0.8 cars. So number of small boxes. So let's count here that big box has, there are 22.5 big box. That means 4.5 big box, and each big box has 25 small box. So altogether it is 4.5 times 25. It is 112. It is 112.5 small boxes in this region where you see 35 and above, and each box contains 0.8 cars, so it is 0.8, and let's multiply 112 by 0.8. This is times 0.8, and our answer is again this is 90. So you can do it either way. You have to see that which way is easy for you, then you can go through that way. But my suggestion is that while practicing this sort of sums, you try in different ways so that things will be clear to you. So we answered question number A. Now we have question number B to answer. Question number B, it says that estimate the value of the mean speed of the cars in the sample. So first of all, we have to develop the table here. So let's write here x, value of x. So I will keep midpoint of each class interval here, and then their corresponding frequency. So midpoint of this class interval is 10 plus 15 is going to be 12.5, and another is going to be, and lastly it is 42.5, and then frequency of the class is, so one box is 20 cars, half box is 10 cars. So altogether in 10 to 15 class interval there are 30 cars. So frequency for that class interval is 30, and this is the mid value of that class interval. And similarly the frequency for this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 to the 24. So this is 224 cars. 450 we have checked through calculator. That means our reading is correct in this case. And in this question number B, it said that estimate the value of the mean speed of the cars in the sample. That means what you have to do actually, you have to do x bar equals to summation of x times f by n. But you don't need to copy out all this in the table. Just you take the calculator and do like this. You know that you multiply these two values and then separate them by sum, and finally put enter to get the final answer. So here in this case I'm doing like 12.5 times 30, okay, and then plus 25 times 240, 28.83333, something like this. So up to 1 dp if you want to express your answer in. So this is 28.8 for 1 decimal place. So our x bar value is, here you can see the x bar value is 28.8. okay, so it hasn't said to express your answer in 1 dp or any significant figure, so you can decide yourself. It is a good idea that, because we are dealing with the small boxes, big boxes, therefore you keep your answer in 1 decimal place. So what will be the unit of that? Unit of this is average speed. This is the data for speed, so you can write miles per hour. Okay, and next we have to estimate to 1 decimal place the value of the median speed of the cars in the sample. So let's see what to do for the median speed of the car. So you can see that all together how many cars are there. So total number of cars in this case is 450. So median value will be given by 450 by truth value. That means it is 225th value. So without using formula, you can estimate the median from the given graph. We have to work out a bit there in order to reach to the median point. So here in this case, if you see that the median point, so this is 225. Fifth item means we are talking about frequency. So let's check here. This one box has frequency 30 and this is half, 20, and this is half, so this is 10. So altogether this class interval has frequency 30. And the same thing we have worked here also. Now another class interval has frequency 240, and from here so you can see that it has frequency 240, but we require up to 225. So let's check how many biggest squares are here. 1, 2, 3, 4, 5, 6. And times 20 is 120. And then let's take the difference of these two. It is 225 minus 150, and this value is, so difference of 2 to 5th and 150th in this case is 75th item. Okay, so if you talk about 150, so up to here is frequency 150, that means up to 20 to 25 class interval is 150, but there is extra frequency 75 that goes in another bar inside here from 25 to 30. Is okay? So it is 25 to 30. So let's see here. This 25 to 30 has frequency 1, 2, 3, 4, 5, 6 to the 12. This is 120. So in that class interval 25 to 30, okay, your frequency is here. Total frequency is 120, and out of 120 we have to check for the frequencies values 75. Then by using the unitary method, if frequency would be 1 in that sense, that means we are taking off unit gap here. So it is going to be 75 by 120. And class interval, let's represent that by C, for example. It is 75 divided by 120 times C. And for this class interval, this is 75 divided by 120, and this and the class interval value is 30 to 35. Sorry, 25 to 30. That means the C value is here. We are talking about 25 to 30. That means C value is 30 minus 25, and that is equals to 5. Okay. So you multiply here by 5 and your answer is 3.125. So what did you understand by that? Let's see here. That means up to here is 150 and there is 75 extra. So we have to move forward from this 125 in the gap of 25 to 30. And by using this method, so how many steps would you move forward from 25? It is 3.125. So 25 is the minimum value for the median, and how many steps forward here? Plus 3.125. So median in this case is going to be, if you add this value, it is going to be 5 plus 3, 8. So this is 28.125. And if you express that to the one decimal place, it is going to be 28.1 up to 1 dB. So median we obtained is here to one decimal place. So median value in this case is 28.1 up to 1 decimal place. So this is the answer for question number C. Now in question number D, this states that comment on the shape of the distribution. So what is the shape of the distribution? So let's discuss a bit about the shape of the distribution. You might have seen this before also, but let's see it again. For example, here in this case, let me compare. I'm taking a rough diagram. So say this is value 0 and mean value, you can see that here it is 28 point
28.8, and median value is 28.1. That means it is somewhere here, 28.1. And the mode value, if you talk about, this is the highest class interval, so mode value is somewhere in this class interval. So mode value is from 20 to 30. So let's see here. Even if you talk about this, so mode value is somewhere in between, so it is definitely going to be less than 28. So it is somewhere here, and suppose this value is the mode value. Now let's consider a bar. We don't need to fix this height at this time because we are just roughly taking that what is the shape of the distribution. So in this case, the mode has maximum height. That means the maximum frequency density. So for this is your x bar value, and this is your median value, and this is the mode value already here. So your distribution will be something like this. So what happens, suppose it is 28 point is here somewhere, it is 28.8, and this is the x bar values. It's okay. So you can see that median always lies at the center, and if the mode is left to the median and it is to the and the mean is right from the median, that means this sort of distribution will be called positively skewed distribution or the data. All right. Sometimes it is also possible that, not in this question actually, your median value is here and mean value is somewhere here, x bar, and the mode is to the right of median, and suppose x bar is here, and your distribution will look like this. So this sort of thing if you get, then that is called the negatively skewed distribution of data. All right, so you should know about all these things. Now if you think of the value of x bar and median, you can see that the median is to the left, mean is to the towards the right of median, where mode you will find it left from this median, because median should always be at the center. So you can say that the curve is elongated more towards right, therefore this is the positively skewed data. So here comment on the shape of the distribution, then means what you can write here, since x bar is bigger than median value, this is the main reason. Since x bar is bigger than median value, therefore the distribution is positively skewed. So this is the answer. Okay. And lastly we have, it says that state with a region whether the estimate of the mean or median of the mean or the median is a better representation of the average speed of the traffic on the roads. So let's check that here some informations are missing out here, and although mean, median, mode all are the averages, but among them you have to see that which one is most appropriate in this case. So because median lies at the center and it doesn't take into account the extreme values, kind can be calculated even though there is no extreme values information, and also for any open-ended classes. So in this case it looks like median is the most appropriate measure of average. So therefore what you can write in this case, that median is the better representation of the speed of the traffic on the road, on that road. So in this way you can write the comment.
Prove everywhere that your boy is the best. Take a look at my face, do a chi-square test. Better than the rest. Catch me on the cable. I got girls equal to the random digits table. I got rap bars, I got X bars, I got fat cars, I got superstar. I'm eating checks mix. Kodiak's being rude, Jake's being rude. I'm a deck statistics.
Okay guys, I hope that you'll be able to solve almost all problems from representation of data from your book chapter as well as from the Cambridge past papers.
I was sitting in class, don't ask me, I'll never pass. I looked at you and could tell that you were in my way. I tried to study for this, but there's that class that I missed. I tried to catch up on notes, but you're still in my way. My thoughts are slowing, random samples each score showing. Time is short, numbers flowing. Problems I'm not knowing, baby. Hey, I just met you, and this is crazy, but here's my number. So solve me, maybe. It's hard to do right. I know you're crazy, but here's my number. So solve me, maybe. Hey, I just met you, and this is crazy, but here's my number. So solve me, baby. And all the other guys got to explain me, but here's my number. So solve me, baby. I sat there trying to solve formulas up on the wall. They gave me nothing at all, cause you're still in my way. I shouldn't borrow or steal. Wait, could these answers be real? I think I'm starting to feel it, yeah, I'm on my way. Now all the steps are showing, light bulb in my head is glowing. Calculator, numbers flowing. Finally got it going, baby. Hey, I just met you,